I can explain the pH scale and determine the pH of an acid or base using various indicators. If given the hydrogen concentration, I can determine pH and vice versa. If given the hydroxide concentration, I can determine pOH and vice versa. And finally, 17.7, I can convert pH to pOH and vice versa. And this sounds terribly complicated. Oh, my friends, this is perhaps one of the easiest things that you will do all year. We've already seen that water is amphoteric. Who can remind me what it means to be amphoteric? Raise your hand. Yes, Lauren.
It's both.
Acid and a base. Why is that? Because a teeny weeny amount of that, of water, if it's just sitting there, will do this. Teeny weeny. It's called self-ionize. All by itself, it'll break up into smaller bits. Okay? How much of that? How much of water will do that? Not much. Once again, I have to tell you, we've rearranged things, and you would understand what an equilibrium constant is after Thursday's lecture. But basically, this number tells you that if the reaction begins, basically, if the reaction begins, the bigger the number, the further down the line it'll go before finally it reaches equilibrium. So if the K value is 25, then it goes way down the line. It almost completely finishes before it finally reaches equilibrium and you can't get any more product out of it. If that is 25, what's 1 times 10 to the negative 14th? How far will water self-ionize before it reaches equilibrium? Here it goes. Ready? Water is ionizing. Done. Okay? That's it. Right there, 1 times 10 to the negative 14th. What does that mean? That means it's just an itsy bitsy amount of water will actually do this thing. Okay? But when it does, it breaks up into equal amounts. As you can see, 1 times 10 to the negative 14th, in order to reach 1 times 10 to the negative 14th and to be made up of equal amounts, if you divide it by 2, what do you get? 1 times 10 to the negative 7th, correct? Okay, so what does that mean? That means that when it self-ionizes, you have equal parts of hydroxide and hydrogen, which is needed to equal 1 times 10 to the negative 14. So we say that water is an acid and the base, and really we can say it's neither, because it has equal amounts of hydroxide and hydrogens. So what happens when you have equal amounts of hydrogen and hydroxide? What do we call a solution that has equal amounts of hydrogen and hydroxide? How about neutral? Yeah, of course, yeah. If you have equal amounts of hydrogen and hydroxide, you are neutral. Okay? Water is neutral because, does it have hydrogens? Yes, but for every hydrogen you have hydroxide. It's in perfect balance. But what happens is that you can add solutions, you can add impurities to water that will change the balance. Okay? But it really is like yin and yang. You've seen that symbol, perfect, it's Taoism, it's perfect balance. But where one is, where it's very dark, what is the light like? Very light, You can even think of it, since it's May the 4th, be with you. Since it's Star Wars Day, you can think of it as, the way it was with Star Wars. At one time, they were a huge amount of Jedi and only 2 Sith, and then the Sith took over. But when there was a lot of Sith, bad guys, there was just a few good guys. Okay? So think of it that way. If you raise the amount of hydrogen ions, you must lower the amount of hydroxide, because together, hydrogen concentration, and listen to me, anytime you see anything in brackets, the unit is in molarity, moles per liter. The concentration of hydroxide and hydrogen together must equal 1 times 10 to the negative 14th. So, what do we call a solution that has an imbalance? But the imbalance is more on the acid side. You have more acid than base. Acidic. What do we call a solution where it's become imbalanced and you have more base than acid? Whatever the concentration of each, what must they both together equal? 1 times 10 to the negative 14th. So, the first thing I'm going to ask you to do is give me the hydrogen. Tell me the number of Jedi when the Sith are this much. Or tell me the amount of Sith when the Jedi are this much. And it's easy, because Jedi times Sith must equal 1 times 10 to the negative 14. Go. A. 5.5 times 10 to the negative 5th. Hydroxide. So hydrogen, don't know. Hydroxide is 5.5 times 10 to the negative 5th. But we know that together they must equal 1 times 10 to the negative 14th. Do some fancy schmancy algebra. It's not fancy, neither fancy nor schmancy, is it? Let's try to be consistent. So if they give it to you in 2 times 10 to the... Okay, here's the deal. This number plus this number should really equal close to 14. It's either going to equal 13, 14, or 15. So that tells you right there that that can't be the answer. Come on, gang. This is simple division. Okay, let's see. Is negative 10 and negative 5 close to negative 15? Negative 14? Yes. Okay, then that must be right. I don't know what you did. Try again. 1 times 10 to negative 14th divided by 5.5. Did you divide the other way? Did you divide 5.5 by? No. I don't know what you did wrong then. Okay, this is the answer, okay? That is wrong. This plus this must equal a number that's close to negative 14. That's a good way to check. You know you've done it right if that answer plus your original question equals a number that's close to negative 14. And by a number close, I mean negative 15 or negative 13. And it's not exactly, it may not be 14 because of these numbers.
Well, how did you know it was negative 10?
Because I put this in the calculator and I divided by 5.5 times 10 to the negative 5th.
How did you know it was negative 10 instead of negative 40?
Help him with the calculator. All right, try that one. I give you the hydroxide. Find for me hydrogen. Whatever answer you get, plus that answer should equal close to negative 14. Eric. 2 point what? 2.8 times 10 to the Is negative 8 and negative 7 close to negative 14? Success. Now, these numbers may be wrong, but at least you're on the right track. Okay? So, got it? One last one. Now think about it. 10 molar H plus is very, very acidic. So what should you find? I don't know. If that's a calculator problem, I can't help you. I don't. It's some kind of calculator thing. I don't know. You'll have to ask somebody who knows how to use the calculator properly. Yes. Because negative 15, and this is really a plus 1, right, is 14. You see, here's the problem. That is completely unnatural. That's unnatural. Man makes those, not Mother Nature. These numbers are going to become mind-numbing for us. Would you like to play around with these numbers for days and days and days? No. So, in the mid-1800s, a scientist with a very redundant name, by the name of Soren, and I don't know why they put a dash through their name, Sorensen, basically Soren, son of Soren. Soren Sorensen came up with a way of taking these numbers, which are really teeny tiny, and the reason why they're very useful is because that's the amount of acidity that they find in nature. For example, my dad, every 5 hours they're doing blood tests, and one of the blood tests that they're doing on him is pH, and it's these teeny tiny little numbers. So he was able to mathematically find a way to take these teeny tiny little numbers and make them into numbers that we can relate to. We call it the pH scale. Now, we don't know why he used the word P. It may have had something to do with, it's just the way scientists sometimes use P and Q to refer to experimental and theoretical or something. But we have decided as chemistry teachers that the P stands for the power of hydrogen. Hydrogen. And I always felt like it needed an echo. Power of hydrogen. You see what I mean? I mean, just to say power of hydrogen. It's kind of wimpy. The power of hydrogen. All right, so pH stands for the power of hydrogen. You determine pH quite simply by taking the negative log of the hydrogen concentration they give you. Okay, I don't know what log is. I could figure it out, but don't care. Really, as a chemistry teacher, all I care about is that log is a button. It's a button on your calculator that you press, and all of a sudden, log appears on your screen. Okay, that's all I need to know. That's all I care about. Something to do with to the 10th power. I don't know. It's magical. It's wondrous. It is the easiest way to determine. Back when I was in high school, we had these log tables. Thank whatever deity you worship that you don't have to deal with log tables anymore. All right, here. So this is how we do it. Hit negative, not minus, please. Not minus. Negative. That's that button down the bottom right corner. Right? Negative. Find the button that says log. And then hit 8.4 second, comma, negative 9. So it should say negative log 8.4 little e negative 9. Hit the button. I can tell you that it's going to be 8 point something. Now, how do I know it's 8 point something? Because from experience, I know that whatever that exponent is, the number is 1 digit smaller than that. Now, you math whiz could probably explain it to me why. I don't care. It's just magic as far as I'm concerned, and I'm quite happy believing it's magic. All I know is whenever I see this number, I calculate, I'm expecting an answer to be 8 point something, and it always works. 8 point what? 8.1. Yay. Now, it may not be 8.1. It's got to be 8 point something. Don't know why. Magic. But it may not be 8.1. It really depends on, did you put these numbers in right? Okay. If you don't put it in right, then it's not going to be 8.1. Try this one. Now, hold on a second. Look at it. I want pH. What did they give me? They gave me the hydroxide, but pH is the power of the hydrogen concentration. So before we can do our pH calculation, what are we going to have to do with that number? Divide it into? Okay, so before we can have fun here with the log button, we need to get it to the right world. So I'm expecting something to the -8 or 9. I don't know. What is it? No, what's the total number? Thanks. I don't know. Okay, what's this answer, folks? This is simple division.
1.3.
Okay, -9 and -6 is 15, so we did it right. Now, negative log 1.3 times 10 to the -9th. And the answer has to be 8 point something. 8.9. It's pH units of 8.9. How about this one? 5.0 times 10 to the -5th. Yes? 4.3. Okay? These numbers are much easier to deal with than all these mega small numbers, micro small numbers. Okay? So, 1 times 10 -1, negative log, it's 1. 2, 2, 3, 4, 5. Okay, here's the pH scale. Water is going to be in perfect balance, so it is neutral. Anything above water is basic. Anything below water is acidic. But really, pH, all that pH can tell you is anything below water, there's more acid than bases. There's bases there, but there's just more acids than bases. And the further down you go on this chart, the more acidic and the less alkaline it is. When you go up, all that it's really telling you is that there is less acid, less acid, less acid, less acid, minuscule amount of acid. Because there is another scale for measuring how alkalinic something is. Okay, so sodium hydroxide, which is lye, which can be found in nature but in very small amounts, is an ungodly pH 14. That means there's a teeny weeny amount of acid in there. Household ammonia. Blood is typically on the basic side. Milk is on the acid side because of what acid? What acid does milk have? Lactic acid. That's right. Vinegar. Wow, pH 3. But wait a second. I eat vinegar with my salad. Yes, you do. Okay, but try spraying that vinegar into your eyes. How will you feel? Your eyes can only tolerate certain level of pH, and if it goes too far below, then your blood vessels really swell up there, and bringing in some fresh blood in order to try to deal with the alkaline or the basic situation. Lemon juice, stomach acid, Coke is down here as well. Any carbonated drink is down there. Okay, the carbonated drink is acidic enough to dissolve the calcium carbonate out of chicken bones. I know that probably your middle school or elementary school tried that. You know, all you get is this rubbery ligament that's left behind. So yeah, this is it. And the key thing that it took me a long time to understand is that pH only really works for natural things. We don't determine the pH of a lot of the acids that we use here in chemistry because it goes beyond nature. If you are beyond 1 molar, then nature nature does not make acids that strong, that acidic, or bases that basic. So when we play around with the pH, we're playing around with the natural world. In the natural world, you do have teeny weeny amounts of these things. So just because I bring you a jar of pH 1 does not mean, oh my gosh, I'm going to die. No. pH 1 is, well, you guys played around with pH with 6 molar. 6 molar is, about 1,000 times more acidic than what Mother Nature can make. Keeping in mind that pH is the world of log 10, how many times more acidic is an acid with a pH of 3 as opposed to an acid with a pH of 5? Most people on the street would go, well, from 5 to 3, that's 2 times. And they would be wrong. Because if you're in log world, you're in the world of 10. In our world, everything is 1 apart. But in this world, everything is 10 apart. So it's 10 times 10, 100 times. So typically, your blood is pH 8. Actually, it's 7.4. So between 8 and 7, let's just say 8. And your soft drink is around pH 3. So 10, 100, 1,000, 10,000, 100,000 times more acidic than your blood. That's why you really should probably be rinsing off your mouth every time you drink cola drinks. Same thing with the Richter scale, by the way. The Nepalese earthquake was around 9, high 8s, right? We here in East Tennessee sometimes experience 2s, 3s. Yeah. Yeah, you're from Florida. One of these days you'll wake up, especially in the morning. I don't know why it happens at night or in the morning, and your closet may be shaking. And that's one of our teeny tiny little earthquakes that we get. Don't worry. 2 is about it. Compared to Nepal, it is, go, 10, 100, 1,000, million. Wow. So our earthquakes are 10 million times nicer than the Nepalese one. How is pH determined experimentally? Those of you who with swimming pools, or you've been to a swimming pool when they're checking the pH, you know that they probably don't use these fancy instruments. We buy these fancy instruments every year and we have to replace them every 2 years. They're just very difficult to calibrate. We use pH paper. pH paper. And you guys probably use some kind of dye where you put drops in a sample of water and it changes a certain color. All of these things are chemicals, and we'll talk about it after the EOC. Chemicals that are made up of these molecules that when they change shape, they'll actually change the way they reflect light. So acids and bases can make it change shapes. So by exposing them to acids or bases, they'll change a certain shape and change a certain color. Litmus is the one you need to remember the most. Okay? Do you remember? What? Red for acid, because red for acid, blue for base. Acid, right? Acid. Okay, how can we determine the alkalinity of a solution? Paul scale. Pole scale. Guess what the equation is for the pole scale, POH scale? POH is equal to the negative log of the hydroxide concentration. In other words, same thing, different world. Before we were talking about Jedis, now we're talking about Sith, but they're the same thing. One is bad, one is good. What is the relationship between pH and POH? Let me show you this, because it's really easy. But I can give you the equation, but it'd be better if you understood it. Okay, when water is in its natural state, you will have 1 times 10 to negative 7th, right, of hydrogen, 1 times 10 to negative 7th of hydroxide, and together they equal 1 times 10 to the negative 14th. Correct? Well, what if we take the pH of this, 7, the pH of this, 7, or the POH of that, equals the pH of 1 times 10 to the negative 14th is, so what do these 7s have to do in order to equal 14? In other words, pH plus POH must equal 14. pH always. Always and forever. All right. I need you to find pH. But wait, what's the problem here? It's an OH. Can we find POH then? Okay, so negative log of 5.3 times 10 to the negative third equals 2 point something, and I know it's 2 point something because it's to the negative third.
I thought it was just log, not negative log.
No, it's negative log.
2.3.
If you're using just log without the negative, then you're getting negative numbers, which is fine. Just make them positive. All the negative is doing is making it positive. 2.3?
Yeah.
Okay, but that's not the answer. That's the POH. I want the pH. No, 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 no. Can anyone think of a different way of doing it? What I consider a longer way of doing this? Yeah, what if you divide it into 1 times 10 negative 14th to get the hydrogen concentration, right? And then take the negative pH of that. Negative log of that, I'm sorry. But I think that's longer because you have to deal with more exponents. For me, the more of these super small numbers I have to deal with, the better the shot that I'm going to make a silly mistake. So I like just going ahead. I can subtract from 14 pretty well. Okay? So all I do is I take the negative log and then flip it over to the other side. How about this one? Find the POH. So what do we do first? No. I would find the pH first and then subtract from 14. Or if you want to do the dividing, then be my guest. Enjoy. I think it's a whole lot easier to do negative log and then subtract from 14. Well, it's going to be 8 point something. 8.1, so 5.9. Is it as complicated as the targets made it sound like? All right. So pH 7.4. What's POH? 14 minus 7.4. Blood cells need to live around 7.4. From 6.8 to 7.4 is the living stuff in blood can live. Outside of that, we're in trouble. What if you needed to go backwards? What if you needed hydrogen concentration and they gave you pH? What are the steps? Okay, here we go. pH is equal to the negative log of the hydrogen concentration, right? Well, what if this is your X? Get negative over to the other side, it's negative pH log of X. You divide by log, which in your calculator means you second log it. I don't know. All I know is if you hit second, then log, it's like dividing by log. It probably isn't, but you know what? In my mind it works, and it works all the time. So, second log of negative pH. So, calculator, second log negative 7.41. It's going to be times 10 to the negative 8th. Did I figure that out because I'm a super math genius? No, because I know that the exponent is always one digit higher than the pH.
7.2.
Can I get an amen on that? Truth. Is it 7.2?
Yeah, that's when you press it, it goes to that 2, and it's second.
Yeah, it should give you 10 something, and then you put down negative 7.41. What?
Yeah. Oh my god. I did that. What?
That's why I have to get a truth from you guys. Can't go with the first answer.
I literally got that, what I gave you.
All right.
Please, Siri, help me with myself.
We good? One more. 6.59. Find the hydroxide concentration. Second log negative 6.59. It's going to be something to the negative 7th. Can I get a truth statement on that? 2.6. All right, we've accomplished all of the targets.